Okay, guys, it's not everybody, but almost there. Let's get started. So welcome to the first lab of 375. Okay, so for this semester, of course, everything will be online, including the lab sessions. Okay, yeah, our TA just joined us. Our TA is Jerry Yamani. Okay, so he will help us for the lab, with the lab, and also creating the homework and lab report for us. Okay. So for construction material labs, the objectives is to, develop the ability to conduct laboratory and field work. But of course, for this semester, we can only do that from lab demonstration. Okay, and also it is very important to analyze and interpret data. Okay, from the lab work, we get some raw results and how use this raw data uh, to analyze and draw your conclusion. Okay. Another objective is to how to develop effective writing and graphic communication using figures and tables together with words to read the technical report. Okay, so this is about the focus for the labs. And also develop teamwork skills. Okay, as you will see, our lab groups will be divided into 5 or 6 person groups. Okay, so in this section, Monday to 30, we have 2 groups. You can find your name here. Okay, so we have group A with 5 of us and group B with 6 students. Okay, so we work together. For the first 3 lab report, it will be individual lab report, which means every one of you will write your own report and submit it. For later lab report, I think lab number 4, 5, and 6, that will be a group effort. So you will write your lab report as a group. So every group will only submit one single lab report. Okay, so you will work together for the future, for later lab reports. Okay, so teamwork is very important for the lab sessions. Okay, I'm not sure how many of us has read the lab report before, but here shows the general format of technical lab report. You need to have a title, okay, introduction, which will give objectives of the experiment, and also introduce the materials you use, the instrument you use for the lab. Okay, this is called materials and experiment sessions. And then the next session will be data typization and discuss the result, analyze the result. Okay, and after that we're gonna discuss the result using figures and tables, and then you will draw conclusions based on the discussion of the result. Okay, and finally, you should give any reference papers, lecture notes, if there are any for reference. Okay, so I will upload an example of technical report, which is a paper about concrete we wrote several years ago. Okay, so this is a journal paper from Yanping Li. She's a graduate master student by me and Riza Mir Moftatai. He is a former PhD student of me, and also he is currently working as a postdoc for the company lab. Okay, and also some other company expert. So the title is Design of Experimental Approach to Study special type of concrete called geopolymer concrete. You can have a look of the paper. We have subject, introduction, experimental program, which is the same as the materials and experiments. Okay, So in that section, we talk about the materials we use, the details of different type of materials. Okay, you can use tables and figures to show the results. Okay. Sand, chemicals we use. Okay. Mixed proportions, what are the mixed design for the concrete. Okay. Mixing procedure, how you mix the concrete, how you cure the concrete, and what kind of test you did for your samples. Okay. For your lab, you don't have to write such a long lab report, but this is the format you should follow. Okay, and then the next session is result and discussion. Okay, from the experiment, you get a raw result, and you need to analyze the result and discuss the result. Okay. So this is one of the most important section, result and discussion. And then based on that, you will draw your conclusion. Okay, right. Okay, we have a long sections on results. So conclusion is drawn at the end of the paper report. Okay, so you should be in the bullet points. Okay, what important conclusion you can draw from this set of experiments. Okay, and don't forget any reference. Okay, papers you use for your reference. Okay. Again, this is the sample technical report. All right, then come back to the first lab. The first lab is very simple. It is called chemical and mineral mixtures. Last week, we discussed silica film, flash, and slag. So this is belong to mineral mixtures. And this morning, we discussed chemical mixtures, such as air entraining agent, superprocessor, retarder, and accelerator, so on. But today, we only choose some of them. Okay, we need to study how the water to cement ratio, W/C, how flash, silica film, and superprocessor affect the flowability of cement paste. So basically, we weigh different type of materials together with water, and we use chopsticks with the cup, drinking cup, and we observe the flowability of the cement paste. Okay, so this is the procedure we should follow. Okay, so for example, we mix 50 grams of cement with 15 grams of water, mixed together with the chopsticks, and we observe the flowability of the paste. And then we add 10 more grams of water. So the water cement ratio will be increased from 0.3 to 0.5. Okay, so then the flowability will be higher, should be higher. Okay. Then the next step is we mix cement with 20 grams of flash. You should, based on that, calculate what's the percentage of flash over total cementitious materials. The total cementitious materials should be 30 grams plus 20, so that's 50 grams. So the percentage of flash will be 40%. Okay. Then we add some water. You can calculate the water to cement ratios, and then you observe the flowability again. Then the next step is we mix 30 grams of cement with 20 grams of silica film. Okay. So that is again 40% of silica film. Then again 25 grams of water. Okay. So compare the result with the previous mixes. And then the final step is we add some of superprocessor into mix C, which is here, and also observe how superprocessor can enhance the flowability of paste. Okay, and this is the procedure And this is the discussion, the question you should try to answer in your lab report. For example, if a cement paste is too dry, how we can increase the flowability. Okay, there's many different ways we can do that. For example, increase the water content, okay, or some other method, okay, you should try to answer. And what are the negative effects of increased water to cement ratio? How flash and silica fuel and the superplasticizer affect flowability of cement paste. Okay, so this is the first lab. Okay, then I'm gonna show you the demonstration. So this lab demonstration is done by Riza. Again, Riza is a postdoc scholar in the concrete lab. He's a former PhD student of me, and also he has served as a TA for this class for several times. In the summer, he taught CE375, so the video is shot by the lab technician. So I think it's a very good quality, and I will just use this for this semester. Okay. So again, this is the first lab.
Okay, guys, I'm going to explain about the chemical and mineral admixture today. That's all of them. For chemical admixture, we work with superplasticizers and compare it with the water and see what will be the role of water inside a, mortar, paste, and concrete, and then how superplasticizers can help us to be used instead of water. And then we will get familiar with actually two types of mineral admixture, the fly ash and silica fume, and how we could replace some percentages of cement with these mineral admixtures. And then compare the workability of cement with and without mineral admixtures, and if we could, change the fresh property of the concrete just by using mineral admixtures. Like before, I'm just gonna follow the instruction I have.
I can't hear the video now.
The paste.
Okay.
And then for the second part.
Is it good?
So let's get started and mix.
Thank you.
So you have to wait for 50 grams of cement. Just to show you guys which is it. So I prepared some containers, including cement. So the first powder is cement, Portland cement. It is type 1, 2 Hawaiian cement. And this one is type F fly ash. As you know, we have two types of fly ashes, type F and type C fly ash. But type C fly ash typically, not all the time, has some impurities. And if I want to select type C fly ash, I might not get the desirable result for the workability I want. And the last one is silica fume, is kind of dark gray, and it is super fine. So the particle size of this silica fume is 0.1 microgram, and for cement and fly ash, the particle size is between 10 to 15 micrometer. When working with either of them, we need to cover our skin. And then don't forget to cover your eyes, use goggles, and the mask should be N95 because silica fume, as I mentioned, is in nanometer particles. And I don't want to inhale them or have them on my surface of the skin because it is small enough to penetrate onto my skin, go to my vessels, blood, and I don't know what happened some years later, so I don't like it. Something happened to me. So I start with the cement. I have to weigh my container like before. Don't forget to weigh your container and then re-zero it. So the container itself is 12 grams. I'm gonna need it later, just write it down and then zero it to make sure whatever I add to the cup is my material. Just grab the material and see when I can get 50 grams of the cement. So it is higher than 50, 60. One more time. It's almost 50. Let's try it a little bit more accurate. Whatever it is, you have to write down the exact number. So it is exactly 50.0. Was lucky. Okay. So in addition to cement, I need water. I need 50 grams of water. I have two choices for water. I can, weigh it, or I can just measure for the volume of the water. You know that the weight of the volume is kind of get easy. So I'm going to use the volume technique, and we have, 5, 10, 15, so on the cylinder, and I can get right on the 15, and it means that I have 15 grams of water if I reach this point. So let's simply add water. So what I'm doing, make my eyes right in the level of the number 15, and then almost, yeah. So I have 15 grams of water, and I'm gonna add this amount of water onto the cement, and then mix it. The chopsticks or whatever you want to use. So as you can see, 15 grams of water could not turn this powder into something fluidable. I try my best to mix all the 15 grams of water with my cement powder. It's wet, not fluidable. I cannot say that it's a paste, still like a wet powder. So for part A, I could successfully add 50 grams of cement and then add 15 grams of water. For the next step, it says add 10 grams of water into the mix. So we already have 15 grams of water, and add 10 more grams of water and remix the paste and observe the change. So we expect that the fluidity is going to accept by adding this amount of water. Let's see. So one more time. I'm using volume technique, and then get to 10, and then add it to my cement paste and remix it. I can say that I have paste now. We don't like to have, high amounts of water in our concrete. The only reason that we like to add more and more water into our concrete is that we need workability. Otherwise, we cannot work with our concrete, we cannot place it well in our forms between our reinforcements, and here you go. So we use 50 grams of cement, 25 grams total water, and you can see the consistency of it. It is fluidable. It is good. Okay, for the next part, it says, so I mix 30 grams of cement with 20 grams of fly ash. for 2 minutes and then add 25 grams of water and mix the paste and compare the result with step B. So it is comparing the roll of fly ash inside our, mixes, because I'm replacing, 20 grams of cement with fly ash and exactly the same amount of water, because I've already have 25 grams of water in the mix number B, and just the only thing that changed was the replacement of cement with fly ash. Let's see. So I need 2 cups to make sure that I'm doing it right. One more time, I make sure that I have the weight of the container. 32.0, and then we zero it. Grab 30 grams of cement. More than enough. It could be a little off, but not too much. Maybe less than 5%. Okay, so 30.0. And then take another cup. Because if I use the same cup that has cement in it, and if I want to add or reduce the amount of new powder, I just mix them up. And I just use a new cup. It is 0. It means that the weight of the cup before and after, 2 containers is the same. So for fly ash, I just use this. I need 20 grams of fly ash. That's okay. So just write down 19.9. And then I can add it to my cement. According to the instruction, I need 25 gram or 25 cc of water. Let's increase the water just to get the level up to 25. And then dump it in my cup. Actually, I need to, pre-mix it when it is dry for 2 minutes, because the unit weight of fly ash and cement are not the same. And if I, mix the water before dry mix the powder, I'm gonna have some lumps of material that I don't want. Just need to make sure that I have these 2 powders mixed well before I introduce water. For 2 minutes is gonna be enough time for dry mixing these 2 powders. The particle size of fly ash and cement are almost the same, so basically 10 to 15 micrometers. So what I'm looking at is this, making sure that I don't see, because the color of cement and fly ash was different a little bit. So I just make sure that I have the mixed color of these 2, and then say that I'm done. So as you can see, you don't see any brownish or grayish areas. So I can say that I could mix them well. And then it's time for introducing the water. I just simply add my water to the mix. And then mix them well. Because, for the cement, I introduced water in 2 steps. I introduced 15 grams of water, mix it well, and then wait, and then add 10 more grams of water. And in that case, I just make sure that I have a stage that we call it rest for the mixing procedure. It means that you have to add water to the mix it, and then wait for some minutes, some seconds, depending on the volume of your mix, and then you remix it. For when you add fly ash into your mix, you have to mix it well, wait for some seconds, and then remix it to make sure that you have the same condition to compare part C to part B. Otherwise, your comparison is not going to be valid. When you add water to the mix of cement and fly ash, you see that it is not fluidable. It is something like that. Adding fly ash worsen your condition, but it is not true. After I wait for a little bit, the surface of the cement covered well with the water, and I think it's the time to compare these two. So this one is combination of cement and fly ash. Just check out the consistency. And here is the combination, just the cement and water. As you can see, adding fly ash could enhance the workability. It is not super high, but you can see the difference. It's more workable comparing to the exact amount of powder and water. So both of them had 50 grams of powder and 25 grams of water, 50 grams of powder and 25 grams of water. And, but the consistency of fly ash and cement was higher, was better. And for the next step, it says that I mix 30 grams of cement with 20 grams of silica film. So I want to compare and see the role of silica film and fly ash besides cement. And then mix them for 2 minutes and then add 25 grams of water and see and compare the consistency of the mix. So one more time, I need 2 cups, 1 for 30 grams of cement. So we zero it. So grab 30 grams of cement. Be as close as possible to the number. That is fine. So 30.2 grams of cement. And use my another cup to grab 20 grams of silica film. So okay, 19.9. And then add them together, try and mix them, exactly what we have for the previous step. When mixing silica film with cement is harder than fly ash and cement because particle size of cement and fly ash are super close to each other. But silica film is much smaller than cement, 1/100 of cement particle. So it's kind of harder to mix them well, but I try my best. Maybe that 2 minutes would be enough, just to make sure that we could mix them as much as possible. And then I also need 25 grams of water. So like before, just repeating the procedure. And then make sure that I mix my powder well. So here still you can see that the dark gray is on the surface, and I can see, brownish gray in between. It means that I couldn't, mix them well. So I continue mixing silica film with the cement, and then add water. Okay, it's time to introduce the water. So I have my 30 grams of cement and 20 grams of silica film. Then to make a paste, I add my 25 grams or 25 cc's of water and add it. So one more time, when I introduce water onto the cement, don't come to any conclusion super fast. You need to wait. So once I introduce water, it's something like this, super hard. I continue mixing and then show you. It is super hard, definitely harder than two previous pastes that I've had with cement and the mixture of the cement and fly ash. The reason could be explained by the particle size of silica film. It is true, we have 20 grams of silica film comparing to 20 grams of fly ash, but because the particle size of silica film is way smaller than particle size of fly ash, we have higher surface area. So imagine that we have something like this, the particle size of something. If I could divide it, split it into two parts, it means that the surface that I have in between, before I split it out, was higher. So the initial surface area was this. When I split it, I have more surface area. Imagine that for silica film, we have 100 particle size. It means that it's not 100 times the splitting for it, something like that. And it is expected that we need more water to cover all the surface, outer surface of silica film. The reason why the consistency of this powder, look at this. So I've done my best, but it's still dry. I've used exactly the same amount of water. The powder was exactly the same, was 50-gram powder, but comparing, for example, with fly ash, it is completely like paste with the exact amount of water. The silica film and cement was not that fluidable. It is dry. Okay. The next step, I think the last part, it says that add several drops of superplasticizer into the mix and then observe the change. So I already have 25 grams of water in the mix because I know if I increase the amount of water, I will get more fluidity, I will get better workability, but the problem is that increasing water will decrease the compressive strength. So I just use superplasticizer. So it's a kind of dark brown liquid, like used oil. Use engine oil. Just add not too much, some drops of super plasticizer onto my face, and then mix it. If it was not enough, add a little more. But make sure that you mix your case well and then decide if you need more super plasticizer or no. The role of super plasticizer in the mix is just this type of super plasticizer has two techniques. The first of them, it has similar charges in the surface of the super plasticizer molecule, and then when it added to the mix, it helped to have just one charge. For example, negative charge in adjacent to a negative charge just repulse each other, repel each other. And the other role of it is that it has some long tails, long polymeric tails that repel the particle of cement or silica fume. The reason why the silica fume or the cement particles can spread all around the case, and we have more fluidity, more workability. I may like to add a little bit, not too much, so you can see it, and then I'm gonna add a little more. So over time, you will get more and more workability. Workable enough. I think just by adding some drops of super plasticizer, I get the same. I don't need any more of the super plasticizer. Is enough. I could get the same consistency as the fly ash and water. It's amazing. You can see. I didn't add any more to bring it a little up. And then check it out. Totally fluid. See? By adding some drops of super plasticizer, and then here was the fly ash. Maybe better than fly ash and water. Just by adding super plasticizer, and then cement and water. Okay, I think I'm done with this session. I mean, chemical and mineral mixture. So you just need to write a report. We have a discussion here, some questions to help you out. I'm gonna upload it in Lolima. You're gonna get it. But answering to these questions will help you to discuss better and just follow the questions. And also you may like to add some information. You can Google search, or you can read your textbook or whatever resources you have. Just make sure that you refer it. You have a reference section and refer them all in your.
Okay. All right. All right. So this is the first lab. Okay. I think Riza and also the lab technician did a very good job demonstrate the first lab and good video shoot and editing. Okay. Again, the lab report will be due September 28th for Monday's group and September 30th for Wednesday groups. Okay. Again, follow the format of scientific writing as the paper, the sample papers I will upload to Lolima. Okay. Okay, and let's see for today's lab. Any questions about that report and the first lab?
Hey, Professor, that video you showed us, is that link somewhere on the on Lolima?
I haven't done that yet. I will upload everything to Lolima. Okay.
Okay. Thank you.
Okay. Thank you.